As these get more difficult, I figured we'd just go through these together, try to knock them out, understand, and then we'll move on back to an SAT type test to finish out the remainder of our time. Keep going over these videos. There's more videos in there in the site. Where does everybody have access to it? Has everybody seen that they have access to it? All those videos. If you don't, I really want to know about that. Apologize for putting you in the wrong one, because I was like, I thought I added her, but added you to the wrong one. So that doesn't help. Okay, 49. The graph of the function y equals f of x consists of 3 line segments. So this isn't any kind of normal looking continuous function. It's just 3 line segments. The graph and the coordinates of the endpoints of the 3 line segments are shown in standard coordinate plane below. What is the area in square coordinate units of the region bounded by this graph, and the positive y-axis and the positive x-axis? So all of that stuff inside that weird area right in here, which I shall erase since I've covered up a point. What's the best way to do this? Any thoughts? Could we split it into 2 trapezoids? Is that the best, or would you like to do something different? I guess it depends on whether you remember your formula for trapezoids, or, I mean, if you don't, then, obviously you can hack this thing up into rectangles and triangles if that's what you prefer. Which way would be easier to you? I don't know. I'll just do the trapezoids, and then if you want to, think about the triangles. So the area formula for a trapezoid is you average the bases and you multiply by the height. Average the bases and multiply by the height. So in this particular trapezoid, this red one that I'm drawing right here, I've got a base of 3 and a base of 4 and a height of 3. So average, so 4 plus 3 over 2 times 3. So what is that? 7 over 2. 3.5 times 3. Who in the right mind? So I guess I could just leave it as 21 over 2. I don't know. Probably going to reach for a calculator here soon anyway. Then with the other one, I've got a base of 2 and a base of... Now, wait a sec. Did I miss something here? I did, didn't I? What's my mistake? I'll show you my mistake. I'll erase it down there at the bottom. That's my mistake. What is that distance at the bottom that I incorrectly labeled 3? It's only a 2. My eyes went to this one right here, and I wrote 3 when I should have been paying attention to the fact that I only moved over 2 units. So that's going to change this. Because now it's a heck of a lot easier because the 2's cancel, and that's 7. Okay. It'd be nice if I would pay attention. Okay, we've got a base here of 1 and a base down there of 2, and obviously a height of 3. So 1 plus 2 over 2 times 3. So that'd be what, 4.5? Because that would be 9 over 2. So 4.5 plus 7. What am I missing? Did I miss something? Oh. Man, they got me twice. Did you see my mistake on the second one? I will show you again where my mistake is on the second one. Down here at the bottom, I'm not paying attention to the x values enough. Why? Because my eyes are going to the 5 and the 3, and I subtracted them and got 2. That is not. So twice now I've made a mistake of paying attention to that one, that x right there, which is probably what they wanted, because the actual length is 3. From 5 to 2 is 3. Man, got to pay attention. Because that will make this, oh, come on. Get rid of that. There we go. So that would be 6. Okay. 6 plus 7 makes 13. Whew. Now, did I lose you on the trapezoid idea? Anybody? Yeah, I did. Okay. So the red one here, I'm gonna lay it down like this. So the red one is kind of like that. Okay. If you kind of disconnect it from the other one and lay it down, and then the green one, that's pretty much exactly the way it looks. And so I really wanted to find these two. And so, you know, if I was paying attention, I would have labeled the sides correctly by using the x's and the y's to do subtraction. Now, did any of the sides not make sense the way I mean, obviously my mistakes kind of got in the way, right? But that's personally what I would have done. Now, if it makes more sense to you to divide it up a different way, and you're like, okay, well, you know, I really would like to see it in terms of triangles, well, and rectangles, well then, you know, go that way and divide it up into those shapes and find each individual shape, you know, your area of a triangle, 1/2 base times height, and you know your rectangle, base times height. So you would just use those with your different numbers. Just be careful. I think your dimensions were 2, 1, and that would be 2. Instead of 4 along that height, you would have a 3 and a 1. So you could do the same type of thing with rectangles and triangles. Would that be easier? Okay. No, it's just whichever one makes the easiest sense to you. Sum of two positive numbers is 151. Okay, sum of two positive numbers is 151. The lesser number. Now, which one do we want to call the lesser number? X or Y? Or does it actually matter? Does it matter? Nope, it doesn't matter. Pick whichever one you want. The lesser one, we'll call that X. The lesser number is 19 more than the square root of the greater number. What is the value of the greater number? Okay, so the greater number would be y minus the lesser number. So that's what they really want to know about what y minus x is. Now, I don't think there's any other way to do this besides substitution. If you can come up with a faster way to do it other than, you know, substitution, great. But I suggest you do this. You take this and plug it in here for x, and I will do the same and see if we agree. Go ahead and work that out. unless you get stuck and you need help. Is that really going to work easily? Or are you already stuck? Because this is what I did. I don't know if that's the best. Maybe I need to do something different here. What if I subtracted the 19 to the other side and got y by itself? What can I do to get rid of the radical? Square it, right? Now that would make my life easier, right? Because now I have y on this side equals x minus 19 quantity squared. Okay, and now I can do the substitution, and it should be a little bit nicer, although I am really out of room here. So I'm going to have to really be careful with my substitution. Okay, so we got x plus x minus 19 squared, because that's my y, equals 151. Okay, so x plus, make sure you FOIL that correctly. Remember, you got x minus 19 times x minus 19. That's really what you're dealing with when you have it squared. So don't just, you got minus 38x. What's 19 squared? Is that 61? Okay. Plus 361. And that's equal to 151. Okay. I suggest we put it all together. X squared minus 37x. And what is 361? Take away 151. 210. Is this factorable? I really hope so. Is that 30 and 7? That would be so nice if it was x minus 30 and x minus 7. X minus 30, x minus 7. So x is either equal to 30 or x is equal to 7. If x is equal to 30, then that would make y 121. Where did I get that from? If I know that x is 30, how do I know that y is 121? They add up to 151, right? That's what they said in the beginning. So if x is 7, then that would make y 144. One of those is a liar. One of those is not true. Which one is not true? If the y value is 144, and I plug it in right there, what's the square root of 144? 12. And what's 12 plus 19? Is it equal to 7? Absolutely not. So this is not true. Now I know with confidence that I take 121 minus 30 and I get my answer of 91. it feels like there should be a faster way to think through that problem. I don't know. I'm going to have to think about that. If I can come up with something faster, I will. Because that seemed like that burned up too much time. The list of numbers 41, 35, 30, x, y, and 15 has a median of 25. The mode of the list of numbers is 15. Now, if that's true, if the mode of the list of numbers is 15, then that means we at least need to have another 15 in the list. Now we have 6 numbers. The middle of that 6-number group is 25. So that must mean that these 2 numbers right here have to average together to get me 25. So what is that? 30 plus x equals 50. What does that mean about x? Nobody knows. It's 20, right? So if we know that's 20 now, we can add them up because it's asking me for the mean of the list to the nearest whole number so I can start adding things together, right? We got 30 right there, and we got another 20, that's 50, and 30 makes 80, and then we can add this over here, that's 76, so 76 and 80. And we can divide that by 2. No, what am I dividing by 2 by? What in the world? Somebody stop me. What should I be dividing by? 6. We got 6 numbers to worry about. So what'd you come up with? 80 plus 76 divided by 6. We get 26. If you disagree, yell now. Okay. You're given the following system of equations where r, s, and t are integers. For which of the following will there be more than one solution with the real number coordinates for the system? Okay. Now, have you seen this before? B squared minus 4ac? And what's the cool nickname that we give that? Where have you seen that before? It's a part of something that you should know and love. It's in the quadratic formula, isn't it? And we call that the discriminant. Look at all those answer choices. Don't they kind of look like the discriminant, b squared minus 4ac? So in my mind, I'm kind of getting the feeling that there's a quadratic that's going to be solved. Now, in order for there to be more than one solution with the real number coordinates, we know that a discriminant has to be positive. Has to be positive because that's the part under the radical, and in order to be, not either create a one solution situation, it can't be equal to 0, and if it's negative, that's creating the imaginary, but they clearly said right here, it has to have real number coordinates. Okay? All right, let's see here. Is there any way I can pause this? You do not have a copy of the ACT packet. Okay. Yeah, I can email you a copy of this. So let me do that. I'll email you a copy of this packet. You can pause it. Well, I record it so you can ignore me right now and then come back later. I'll email you a copy. Let me just quickly do that. See if you can do this for me while I'm emailing him. See if there's a way you can tie these things together. Now, I'm guessing that we should probably take the second equation. Ooh, no. I am wrong. Take the first equation, substitute. Take this x squared and replace that y right there. And then we'll see what you get. So we did our substitution, moved everything over to one side, and we started going through the discriminant, b squared minus 4ac, using our letters. B goes with R, S goes with A, negative T goes with C. Which one of these answer choices, F or H, are we talking about? You know what negative 4 times negative T is? Do you know what negative 4 times negative T is? It's positive 4T. Plus there's that S in there. So this term right here is a positive one. And we said that that discriminant had to be greater than 0. So ding, 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 letter choice F is what we're dealing with. Any questions on that? I just followed the discriminant. I had to do the substitution, get everything on one side, and then pick off my ABC and look for the one that was greater than 0. Can't be equal to 0. 53. The third and fourth terms of an arithmetic sequence are 13 and 18 respectively. What is the 50th term of the sequence? Okay, so 1, 2, 3, 4. Arithmetic terms are found by adding the same number every time. So the third term is 13, and the fourth term is 18. So can you tell me what we're adding every single time? We're adding 5, right? The common difference is 5. Can you work your way backwards and tell me what the second term is? Just curious. If you're adding 5 to move forward, what would you be doing to go backward? You'd subtract 5 and subtract 5 again, right? So the first term of this whole thing is 3. Now, I don't know if you remember your arithmetic sequence forms. The 50th term, now, for those of you that are really, this is not anything different than using the point slope form of the equation of a line. So if you think I'm, coming up with some magical formula, it's really just a linear function. So, and if I put that on the other side, it would, this term right here, it would make more sense to you. So I've got the first term, I've got the common difference, and I'm looking for the 50th term. So I'm literally just plugging in information that I have. It's like I'm using the coordinate 1, 3 and 50, question mark, because I don't know what a sub 50 is. So it's just a linear function, that's all. So what is 3 plus 5 times 49. $248. One of the following graphs in the standard xy coordinate plane is the graph of y equals sine squared x plus cosine squared x over the domain from negative pi over 2 to positive pi over 2. Okay. Yeah, there's 5 choices. I wish I was paying more attention. I can tell you that letters F and J are ridiculous answers. Now, it might be better if I zoomed in to show you why F and J are ridiculous answers. Domain goes with what? X's or Y's? Those are X's. But if you look at letter F and letter J, their domains, they're using the X values on the Y axis. Okay, so a little bit ridiculous there. Do you guys recognize this? This is called the Pythagorean identity. And sine squared x plus cosine squared x is pretty famous because it equals 1. Now, if you look down here at letter H, that's the answer to this question. Why is this the answer to the question? Because it's constant. It's y equals 1. So if you knew the Pythagorean identity, sine squared x plus cosine squared x equals 1, you would know that you're getting a horizontal line. You're not getting anything that changes. You're getting something that's completely constant. It's called the Pythagorean identity. Okay, now, this one might be a touch, a stretch for you guys. I mean, literally in... So the cosecant function, maybe I should remind you, this is where I think they go a little bit farther than plain old Algebra 2. Are you guys familiar with sine, cosine, and tangent? SOHCAHTOA? I'm sure you are. I don't know if you are familiar with cosecant, which is the reciprocal, and we usually abbreviate it CSC. If it's the reciprocal, then it flips the hypotenuse and the opposite. Then there's the secant, which is the reciprocal of the cosine, and reciprocal would flip the hypotenuse and the adjacent. And then there's another one called cotangent, which is the reciprocal of this. So if you know SOHCAHTOA, welcome to its cousin Choshikau. The one they're referring to is this one right here, cosecant, and it goes with sine. Now, they're hoping that you know what a sine function looks like. A sine function has the basic shape that looks like this. It starts at 0 and it goes to 2 pi. And it will continue to do that forever and ever on the other side, and just keeps doing that. This would be over here would be negative 2 pi. It's interesting. This seems to be. I'm kind of surprised they would throw this one at you, quite honestly. Oops. That's a standard sine function. What do they have here? They have a change to that sine function. So not only is it a reciprocal, which we'll deal with in a second here, but they have done some sort of scale change to the x's. Do you know what kind of scale change they've done to the x's? For those of you who don't know what the scale change on the x's would be, and if you've heard the phrase fireproof form, it would look like this. If you wanted to get that to be a 1x on the top, you would have to multiply the top and bottom by the reciprocal 1/4. And so we have a sine function which has been horizontally shrunk. Horizontal shrink. Can I spell? Shrink by 1/4. So if you think of this sine function and you shrink it down by 1/4, what do you get? Whoops, that ain't it. Now, do you have, you got a graphing calculator here? This might be a better, we'll take a look at that in a second, because that might be a faster way to handle this question. If you shrink this by 1/4, this shape would have to do this. It would have to complete the cycle in that amount of space. It's not half, it's 1/4. So if this is pi, this would be pi over 2. It completes, so they have shrunk this thing down. Now, what happens when they do the reciprocal? I am surprised they threw this one at you, so maybe we should do this with a graphing calculator. Because a reciprocal would mean that every single x-intercept would become what? Every single x-intercept would change to what? A vertical asymptote. And it would do that over and over and over and over again. So, the shape that you would end up getting, they look like these fake parabolas. They have to stay within their asymptotes. Now, how far are those red vertical asymptotes away from each other? What is 1/2 of pi over 2? What is 1/2 of pi over 2? Anybody know half of pi over 2? Out of those answer choices, which one of those looks like half of pi over 2? So 1 times pi is how much? One times pi. Okay, folks, 1 times pi and 2 times 2. Looks like that one right there. I want to see if we can graph this on our calculators faster so that you can kind of get the feel for it. Let me bring up my camera. And yep, I unplugged it, so I'm going to have to plug it back in again. If I can plug this one in down there. And close that out. If you have a graphing calculator, Once I bring this up, we'll see if this can go a whole lot faster. Come on, zoom in. Okay, the first thing that we would need to do is we would need to change the mode on our calculator. Okay, so the mode button right about in here, we would need to make sure that the calculator was in what we call radian mode. So make sure it's not in degree mode. Next, we need to type in the equation. Now, there's no cosecant function on your calculator. So they are really they really need you to understand that's 1 over sine 4x. You have to know that cosecant goes with sine in order to be able to type that. Now our window probably has to be set correctly, so I'm going to go to our window here, and let's just say we want to go from 0 to 2 pi. So, you know, that's more than enough. And we all know that the minimum and maximum for a sine function, well, we could just leave it at -10 to 10. Maybe that'll help us understand the picture. And we can go to the graph. And you can see all these little fake parabolas being drawn in there. So the question is, how far apart are they? Now, my scale doesn't look all that great. You can see that my hash marks are kind of in the wrong spot. It would be smarter of me if on my window, my x scale was something nice. Maybe I said pi over 2. That might not be perfect, but at least it will get me the right idea. It's going to have the same looking picture, but now I can kind of see the hash marks on my screen. And I can see that every time we get to another pi over 2, we've done 2 of those little things. And you know what? I was wrong. Wait a sec. Because one's right side up and the other one's upside down. So it completes the cycle every pi over 2 units. Not every pi over 4. We don't cut that in half. Good thing I checked. It's repeating the cycle every pi over 2 units. So that was a mistake. They would have gotten me on that one if I was just continuing to go as fast as possible. So, if you haven't done much with trig, it might be to your advantage just to do the graphing on the calculator. See how long it takes to repeat the pattern over again. That's what they're getting at. The period of the function is how often it takes to repeat the pattern. Okay, at a school carnival, Mike will play a game in which he will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with heads face up. Let the random variable x represent the total number of points awarded on any toss of the coin. What is the expected value of x? Okay, so we've got x and we've got the probability of that happening. He will toss a penny, a nickel, and a dime at the same time. He will be awarded 3 points for each coin that lands with the heads face up. Let the random variable x represent the total number of points awarded. Okay, is it possible that he could get 0 points? That is possible, right? That would be all tails. He could get 1 head, 2 heads, or 3 heads. So these are the possible outcomes for his number of points. Okay, this does require you to know the probabilities. Maybe we should just write out, we've got heads, 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 tails, heads, tails, heads, tails, heads, heads. We could also do this with 3 tails, and we could, if you'll notice, I am just moving the one value or the one item over one at a time as I go through this. There are 8 different possible options. So each one of these probabilities is over 8. How many of those would be no points at all? Wouldn't that just be that one right there? So that would be 1 out of 8. How many would he earn 3 points? Where he's only got 1 head. So that would be any of those 3 options. So that's a probability of 3 out of 8. How many would he earn 6 points on? Everyone that has 2 heads in it would be 6 points. There are 3 of those. And there's only 1 left that would be his 9-point win. Now, to be quite honest, if you want the expected value, if you have a calculator, a graphing calculator, you can do this. You can make these 2 lists. And the calculator feature that you're looking for is sum list 1, list 2. That would actually do what you want. But if you want to do this the hard way, or I should say, the more explained out way, you multiply these things together. Well, 0 times 1/8 is going to not be all that eventful. 3 times 3/8 would be 9/8. 6 times 3/8 would be 18/8. And then 9 times 1/8 would be 9/8. If you add those together, what is 9 plus 18 plus 9? 9 plus 18 plus 9, how much? 36. Now, which one of those answers is 36 over 8? 36 over 8 is not a whole number. 36 over 8 is 9 over 2. Now, that's 4.5, isn't it? Isn't 4.5 smack dab in the middle between 3 and 6? How in the world, is there any way that I could have guessed 4.5 without doing all this work? I know that this is the right way to do this question, but there is something that kind of lends itself to me guessing 4.5. What type of distribution do we have? 1, 3, 3, 1. We call that symmetrical. It's balanced. It's not heavy on one end versus another. It's perfectly balanced. So right smack dab in the middle would be my expected value. That would be one way I could look at this. All the math that I did there is technically what you should do, especially if you have an unbalanced group of data, but we have a nice one. I've never seen a matrix question on an SAT. But notice what they tell you in this question. They tell me how to find the determinant of a matrix. Now, I always tell my students to take the product of these two numbers, put that above this corner, and the product of these two numbers, put that above this corner, and then subtract them. It's exactly the same thing as what they're telling you. That's how I kind of direct my students to do it. Okay, so if I do the same type of thing, if I take k times k, that's k squared, minus 3 times 4, that's 12. For what positive real value of k, if any, is the determinant of this matrix equal to k? How do you solve that? Any thoughts on how I'm going to solve that thing? Looks like a quadratic. I'm hoping you'll push this over to the other side. K squared minus k minus 12 equals 0. Is this thing factorable? Are there factors of 12 whose difference is negative 1? Can you think of any numbers that multiply together to give you 12 that would make that work? Multiply together to give me negative 12, but they have to add up to negative 1. Negative 4 and 3. How come negative 3 isn't one of the answers? I see positive 4 as one of the answers, but why isn't negative 3 one of the answers? What's the question say? Does the question give me any information about k? Positive real value right there. So that means this one can't be giving me the correct value. Positive 4 is the only value that makes it true as long as it's a positive real number. Okay. Take a break. Stretch your legs. Go get a drink. I hate it when I do that. I was on a roll. I had my circle of eye joke and everything. Seriously. Man. That's bad when I miss out on those opportunities. The different powers of I. I to the first, I to the second, I to the third, and I to the fourth. So just as a recap, you literally can I, negative 1, that's I squared. Negative I, that's I cubed. And then I to the fourth is 1. So this pattern continues. I, negative 1, negative I, whoa, don't move on me, negative I, and 1. So every fourth number in the list is a 1. And it just goes on that circle around and around and around. And I'm sure for the viewers at home, that might not make a whole lot of sense unless you study this picture a little bit more, understanding that you're dealing with powers of the complex number I. I to the first, whoa, stop, I said stop. I squared, I to the third, which is equal to the negative I to the fourth, which is equal to 1. And then when you do I to the fifth over here, you'll see that it returns back to the top of the circle. And it just keeps going around and around and around. And so the answer to this had to be the first one because they stopped with n has to be a multiple of 4. Oh. I wish I had recorded that entire conversation much better than I just did. Okay. Okay, so the sine function normally from negative pi over 2 to pi over 2 looks like this. From negative pi over 2 to positive pi over 2. Now that's the normal sine function right there. But they threw in this absolute value thing. What does that do to the picture? Especially, what does that do to those negative parts down there? What does it do? Come on. When you take the absolute value of something, what is it? Especially of a negative number, what happens? Do you know the absolute value of negative 3? It's 3. It's the distance away from 0, right? So in other words, it changes it to a positive value. So what's going to happen to this branch that's down here when you take its absolute value? All these negatives become positive. So the picture changes. Oh, by the way, that's a 1 right there. That's kind of important. The picture changes to this because of that absolute value. Now, let's see if we can understand their question. When is this function, sine, the absolute value of sine theta, greater than or equal to 1? When is this function greater than or equal to 1? Well, that's y equals 1 there, folks, right? I don't think there's a whole lot of greater than going on here. But there might be an equal to. It's equal to at that spot and at that spot right there. What are those two spots? I have them written in purple. Pi over 2 and negative pi over 2. Choice A. It's not a range of values, folks. It's just those two values, and that's it. Now, if they had said greater than or equal to a half, okay, well, now they're going to they'd make my life a whole lot more difficult. But they made it greater than or equal to 1. And the greater than part is laughable because it doesn't go above 1. But it does equal 1. Okay, ray PK bisects angle LPM. All right. So I'm just going to draw an angle. I might be completely wrong here. LPM and PK bisects it. Okay, so that means this and this are the same. The measure of LPM, so the whole thing, is 11x. Okay, we'll keep that in mind. LPK is 4x plus 18. Doesn't that make this also 4x plus 18? If it's bisected? So that would be a total of 8x plus 36, and they told me that is 11x. I'm pretty sure you guys can do this one pretty quickly. Now, tell me why the answer is not 12. Because I got an x value of 12. All right, I subtracted that over to the other side. I got 3x. I divided by 3. I got 12. Why am I wrong if I choose letter F? Did they ask you for letter X? No, they asked you for KPM. So I'm pretty sure you need 4 times 12 plus 18. And what do you get when you add those together? 48 and 18. I think that's 66. Any questions on that one? I know those toward the end were getting kind of hard. That's what they want you to do in 60 minutes. Yeah, that's a tall order for anybody. Okay, let me get you a different test here. 989.